And now let's take the solution to exercise 11 together. If we look at the two set of questions, we'll see that the first set of questions talks about angle of a line, and the second set of questions talks about angle between two lines. Now, to do this now, let's begin with establishing the facts around angle, okay, of a line. We know that if you have a line represented by y is equals to mx plus c, the angle of the line is evaluated by saying that tan theta is equals to m, where m is the gradient or the slope. Now, if you have an horizontal line, or let's say y is equals to c, where x is equals to 0, definitely we're saying that m is equals to 0 and tan theta is equals to 0. Therefore, we're saying theta is equals to 0 degrees. This is for an horizontal line. Moving on, if you have a vertical line of x is equals to k, that means we are saying that y is equals to 0. And if y is equals to 0, m is undefined. And if m is undefined, our theta is equals to 90 degrees. M is undefined. Then theta is equals to 90 degrees. Now, this is for angle of a line. What if we are considering angle between two lines? Let's write that here. Angle between two lines. That means we are saying we have y is equals to m1x plus c1, and likewise y is equals to m2x plus c2. So we are saying that the angle theta is generally represented by modulus of m2 minus m1 divided by 1 plus m1 m2. This is for non-perpendicular lines. And if you now have parallel lines, and in parallel lines, we know that the gradients or the slope are equal. So we are saying that m1 is equals to m2. And if m1 is equals to m2, theta is equals to 0 degrees. And if we have perpendicular lines, and in perpendicular lines, the product of the two gradients, that's m1 multiplied by m2, is equals to -1, and this means that theta is equals to 90 degrees. So now let's solve the two set of questions with analogy to the angle of a line and also angle between two lines. So let's duplicate this, move on to the next page. Now we can see now that the first question, question 1, says y is equals to 7. Now y is equals to 7 shows that it is an horizontal line of y is equals to c. And if you come back to this section, that if you have an horizontal line, m is equals to 0. And if m is equals to 0, theta is equals to 0 degrees. So for this horizontal line, if you compare it to mx plus c, we can see that m is equals to 0. And if m is equals to 0, if we use tan theta is equals to 0, or tan theta is equals to m, and which is equals to 0, then theta is equals to 0 degrees. This shows horizontal line. Moving on, so we have solved question 1. Let's solve now question 2. X is equals to -2. X is equals to -2 represents x is equals to k. And if x is equals to k, theta is equals to 90 degrees because m is undefined. So x is equals to -2 represents x is equals to k, and this shows that m is undefined. And if m is undefined, if we follow after tan theta is equals to m, then theta is equals to 90 degrees. Moving on to question number 3, where we have 2y is equals to 3x plus 2. Now this brings us to the normal expression of a line of y is equals to mx plus c. And the normal expression of a line now, with this we have to find divide all through by 2. If you divide this by 2, divide this by 2, and also divide this by 2. We will then have that y is equals to 3 over 2x plus 1. Having y to be equals to 3 over 2x plus 1, we can then compare it to y is equals to mx plus c. So with this, we have the expression, the value for m, to be equals to 3 over 2. Now, if m is equals to 3 over 2, we go back to our formula of evaluating the angle of a line. That's tan theta is equals to m, where theta is the angle of the line. So making our substitution of m to be equals to 3 over 2, we have that tan theta is equals to 3 over 2, which is simply 1.5. Therefore, we can evaluate theta now to be arctan of 1.5. And using our calculator to simplify the arctan of 1.5, we'll have theta to be equals to 56.31 degrees. So we have solved the first section of this question. Now let's move on to the second section. In the second question, we have to evaluate the angles between two lines. So let's duplicate this and move to the next page. So now let's begin with the first question that says y is equals to 4x minus 7, and likewise we have 2y is equals to 8x plus 5. The first thing to do is to check out the gradient, that means the slope. Are they equal, or is the product of the two slopes equals to minus 1? If the product of the two slopes is equals to minus 1, we have that the theta is equals to 90 degrees. If the slopes are equal, then we have that the angle between the two lines is 0 degrees. So let's go on. Now let's divide all through by 2 so that we'll have it in the manner of y is equals to mx plus c. Divide all through by 2. So this will have y is equals to 4x plus 5 over 2. Now, if you compare this now to y is equals to m1x plus c1, and likewise y is equals to m2x plus c2, we can see that m1 is equals to 4. We can also see that m2 is also equals to 4. Since m1 is equals to m2, that means they are parallel lines. And if they are parallel lines, then theta is equals to 0 degrees, just as we have established here. So we have solved the first question in the second set. Let's move on to the second question. The second question says we should evaluate the angles between the equation of the line. This should be y. Y is equals to, okay, so we have y is equals to 4x minus 2, and likewise we have 4y is equals to minus x plus 4. So let's solve this together now. The first thing to do is to bring it in the order of y is equals to mx plus c. So for this, we have to divide all through by 4. Dividing all through by 4, we'll have this to give us y is equals to minus 1 over 4x plus 1. So comparing these equations now to y is equals to m1x plus c1, and likewise y is equals to m2x plus c2, we have that m1 is equals to 4. We also have that m2 is equals to minus 1 over 4. m2 is equals to minus 1 over 4. Now, we can see now that m1 is not equals to m2, so they are not parallel lines. However, the product of m1, m2, which is 4 multiplied by minus 1 over 4, is equals to minus 1. And this shows that they are perpendicular lines. Perpendicular lines. In perpendicular lines, just as we have here, that theta is equals to 90 degrees. So theta here is equals to 90 degrees. Moving on to the final question, we have 5y is equals to 10x plus 15. 5y is equals to 10x plus 15. And likewise, we have the second expression of 2y minus x is equals to 4. 2y minus x is equals to 4. Now let's put them in the form of y is equals to mx plus c. So for that to be done, we divide all through by 5 for the first equation. Divide all through by 5 and by 5. So we'll be left with y is equals to 2x plus 3. And if we divide all through by 5 here by 2, we will have y minus 1 over 2x is equals to 2. Let's bring 1 over 2 minus 1 over 2x to the right hand side. So we'll have y is equals to 1 over 2x plus 2. Now with this, we can now compare the two equations together. This is 1 over 2x. Let's compare the two equations together. First, we'll compare it to y is equals to m1 x plus c1. And second, we'll compare it to m2x plus c2. So with this, we can see that m1 is equals to 2. Okay, m1 is equals to 2. And here we have that m2 is equals to 1 over 2. So we check for parallel lines, we check for perpendicular lines. We can see that m1 is not equals to 2, is not equals to m2. Likewise, m1, m2 is not equals to minus 1 because 2 multiplied by 1 over 2 is equals to 1. So with that, we go back to our general formula of evaluating the angle between two lines. So with that, let's write the general formula. Let's use the red pen. The general formula states that tan theta is equals to the modulus of m2 minus m1 divided by 1 plus m1 m2. So making our substitution, we can evaluate tan theta to give us the modulus of m2, which is 1 over 2, and m1, which is 2, minus 2 divided by 1 minus 1 over 2 multiplied by 2, plus rather. And this will give us the modulus of 1 over 2 minus 2 is 3 over 2 divided by 1 plus 1 over 2 plus multiplied by 2 will give us 1. So this will give us the modulus, this is minus 3 over 2, which is the modulus of minus 1.5 divided by 2. So simplifying this, 1.5 divided by 2, we will have 3 over 4, which is minus 0.75, and the modulus of minus 0.75 is equals to 0.75. Now with that, we have that tan theta is equals to 0.75. So we can easily evaluate theta to be arctan 0.75, and using our calculator to evaluate this, the arctan of 0.75 is simply 36.87 degrees. So with this, we have come to the end of angles of a line and angles between two lines, and everything is summarized in these two expressions: angles between two lines and angles of a line.